Hello. In the previous video, we learned how to calculate the mean and the variance of a binomial distribution. Only if you know the parameters, then you can calculate the mean and variance. And in this example, n equals to 10, p equals to zero point 0.2. So using these two formulas, you get expectation of 2 and variance of 1.6. By the way, I fixed the typo now. Um, so it shows that even if you randomize your answers in the assignment, still you can expect 2 points out of 10. So if you did not get 2 points, that is a that's a shame. So then try that. Like if you could not get 2 points, then there is a serious problem. At least you can just try again and randomize again. Then you may get at least like better than 2. So think about this. And from now on, we are going to think about more examples. Here is another interesting example application of the reservation and cancellation story. So, as you may know, airlines sell more tickets than the available seats because they know that some of the reservations will be canceled. So, to maximize their revenue, they sell more. Literally, they accept more reservations than the available capacity. And if it's there are too many passengers to take the airplane, then they upgrade some of them to business class or give some incentives to take another flight. Anyhow, you may know what happens. So we will study that with some simpler numbers. Suppose that an airplane has 20 passenger seats only. Maybe you may generalize it to like several hundred, but simply consider 20 passenger seats, 20 seats, and but there are only 20 seats, but the airline accepted 22 reservations, sold 22 reservations, oversold 2 tickets, and probability of cancellation is 10%. And as usual, cancellations are independent. And we define y as you clearly see from the assumptions, y is a binomial distribution if we define it as the number of reservations that are not canceled. We define as number of reservations that are not canceled because this is those passengers who actually want to take, who got the boarding passes. So you have to accept them, like take them to the destination. And we are interested in the number of passengers who actually came to the airport. Then what are the binomial parameters for this random variable? It's easy. We know there are 2 parameters. And think about this. It's a little bit still, it could be tricky. So think about what it is. There is no algebra, but it is important. And do this, and I will turn to the next page in 3, 2, 1. So the trick is, first, I am counting the number of not canceled reservations, non-cancellations. In our previous example, I counted number of cancellations, but here I'm counting the other side. So then what it matters, because if you count cancellations, P was the probability of cancellations. But now I am counting the number of non-canceled reservations, then P, the parameter, has to be the probability of non-cancellation. Because by definition, what we count is success and P is the probability of success, right? We consider success and failure, but success means not like doesn't mean anything, but by construction, by definition, it has to be what we count, right? The binomial distribution is defined as the number of successes, right? Not failures. And P is the probability of success. So in this case, P is 90%. Parameter, if you use 0.1, so it's trap, I gave you 10%, but the parameter you have to use is 90%. That's first trap. And second trap, there are two numbers, 20 seats and 22 reservations. What is N? I have to think about this, and it's easier because N is, you may think it as N is the number of trials, or alternatively, an easier way to understand the parameter is that it's the maximum number of Y. Maximum possible value for Y is the parameter N. In this case, the maximum number of Y is 22 when no reservation is canceled. If all passengers want to take the flight, then you will get 22 passengers in the gate. So the parameter is 22. 20 is just a fake. It doesn't mean anything. It has nothing to do with the distribution, right? The number of passengers you will have depends only on the number of reservations made, not about the seats, number of seats. Okay, then what the probability we are interested in is often this guy. The overbooking causes problems if more than 20 passengers want to take the flight. So there are 20 seats, but if 21 passengers came to the airport, you are in trouble. You have to do something. What is this probability? What's the probability of the problem, the trouble? Unfortunately, so what I want to explain here is the probability with inequality. What is the probability greater than 20? There is no direct way. The only way to calculate this is to break down this inequality into single equalities like this. So we are interested in probability that the number of non-cancellations is greater than 20. Then you have to count probability of 22 and probability of 21. So there are only two possible cases that satisfy this inequality. Strict inequality has two possible cases, and then you have to calculate probability for 22 using the formula and 21 using the formula. So when 22 passengers came to the airport, the probability is 22 chooses 22, which is 1. And non-cancellation happens 22 times. Cancellation did not happen. So the exponent of 0 makes it 1 equal to 1. You are not multiplying anything. So it is 1 times 9.848 times percent. So this part equals to this, and this part equals to 1. And for 21, 22 chooses 21 times, 0.9 happens 21 times, and 10% happens once. So you get this. And if you multiply them and sum, you get 33.920%. So in many examples, you want to calculate inequality, probability defined by an inequality, but that is more complicated. So already the probability for one value is complicated, but when you have inequality, it's even more complicated. But with Excel, you are going to use a calculator or a program, so it shouldn't be a big problem. Then try this. I will change the question a little bit. So look at this. Because you oversold the reservations, you are in trouble with almost 34%. 1/3 of the flights are overbooked and you are in trouble. You have to compensate or to arrange something else, which is too much of a problem. So you reduced the number of reservations you accept down to 21. Previously you sold 22 tickets, but now you sell 21 tickets in this case, what is the new probability of y greater than 20? Think about the parameters for y and then use the probability formula to calculate this probability. Do this math, do the exercise, and watch the next video. Thank you.